Okay, beginning with problem number 9, they're asking me to find the equation of the tangent line drawn to g of x at x equals 1. Okay, so things that I know that x equals 1. I want to find g of 1 before I do anything else. So if you plug g of 1 in, let's see, we're going to get you have your 1, so 1 minus 4. So what do we have for 1 minus 4? That's negative 3. So this is negative 3 raised to the third. So 3 times 3 is 9. 9 times 3 is 27. So therefore, keeping the negative, we have negative 27 for our g of 1. Now notice, I've done that before I took any derivatives, because I think the biggest problem with these kind of tangent line questions is that you forget what you're trying to do. So now what I'm going to do is I'm going to say, oh yeah, I am trying to figure out the equation of a tangent line. So I'm going to do this for myself. They have given me x1 as 1. I don't know the slope yet. That comes with the derivative. I have just figured out that negative 27 is y1. So I'm going to put this in my equation. Notice how the negative flipped the sign to a positive 27. All right, you are looking for slope. So now let's find it. So g prime of x equals, okay, here comes the power rule. Okay, don't forget to put your power back up. And you have the chain rule. So I'm just going to take a quick second and pull things to the front. So that's 6x, x squared plus 4 squared. Now I'm going to evaluate this where x is 1. Okay, so that's going to be 6 times 1, which is 6, and 1 plus 4 is 5 squared is 25. So what is 6 times 25? Oops, okay, let me go back for 1 second. Did you see what I did incorrect? So I want this, taking my derivative, that's going to be a subtraction. So let me fix this. That's a subtraction. I have 1 minus 4, which is a negative 3. So let me change this. Okay, so that's going to be a negative 3. And negative 3 squared is a positive 9, and 9 times 6 is a 54. So where does this 54 go? It's going to go right where I have my m. So why don't we erase our m, now that I know what I'm doing, and in that spot, put your 54, and here's your equation of the line, all nicely done. Alright, okay, let's go back, let's go on to number 10, because that's another equation of a tangent line. So let's do the same procedure. I see that x is 1, so here let me just change my color so that you can tell the difference between the two problems. So right away I know x equals 1. Before I do anything else, I'm going to find out what g of 1 equals. So if you put in a 1, I'm going to have 2 plus 1, which makes that 3, and 3 raised to the 4th power is 81. Alright, so now I have my g of 1. So at this point, let's follow the pattern we put forth in problem 9. Write the equation of the tangent line. Fill in what you already know. I know my x was 1. I don't know my slope. I'm going to work on that when I take the derivative. y1 is 81. Alright, so now take your derivative. So g prime of x equals, power rule, 4 comes in front, 2x cubed plus x squared. Don't forget the power. Now I'm just going to put this under here. So the derivative of the inside is going to be 6x squared plus 2x. Alright, so you've got to figure out what that is. So if I plug in a 1, I will have 4 times, let's figure it out, 2 times 1 is 2, plus 1 more is 3. 3 taken to the third power was 27. And then that's going to be times, let's say I'm going to have 6, 8. So I'm basically going to have 32 times 27. So that I'm getting to be 864. Okay, that's my slope. So in the interest of space, why don't we erase our m here, and I'm going to erase a little bit of the equal signs as well, and in its place let's put our slope, which was quite a large 864. And there you have your equation to the tangent line drawn to your gx function. Okay, let's go on. We're going to find critical values in the next 2 problems. Okay, in problem 11, they're asking you to find the critical value. So what does that mean? You should be remembering that that means take my first derivative, set it equal to 0, and solve for my x's. Alright, so let's begin that procedure. So I'm going to take my first derivative, f prime of x equals, oh look, I have the product rule. So my first term is the 6x squared, my second is going to be the x minus 1 cubed. So I'm going to say left, d right, squared, and then the derivative of the inside is actually 1. I'm going to put it there for completion. Okay, plus right, d left. Alright, so now we have that set up. So let's see if we can clean this up a little bit. So f prime of x equals, so I have a 6x squared and a 3 out front. So let me bring that together. So that's going to give me 18x squared, and then that's multiplied by x minus 1 squared, plus I'm going to bring the 12x in the front, and that's multiplied by x minus 1 cubed. Alright, so what I want to do, I want to get this in factored form because that's going to help me to take the critical value. So looking at this, I believe so far I have a, let's see, probably a 6x in common, and I also have an x minus 1 squared in common. Okay, I always use my brackets so that I know I'm doing greatest common factor factoring. Okay, so given that I've pulled out 6x times x minus 1 squared, how do I get that back? Well, I need a 3x, and that's all I need because I have already x minus 1 squared. Pull down your operation over here. Okay, now look what I have remaining. I need a 2 because I need to get 12x, and I pulled out a 6x. And then I also need 1 more of these. Okay, so now in the box, let's clean this up. So I'll change my color so you don't think I'm doing anything that you can tell what I'm doing. So 3x plus 2x minus 2 is what I have. So that's going to end up being 5x minus 2. So how are we going to pull all this together? So let's go one more step. I'm going to get the other color back. Alright, so I have for my derivative f prime of x equals, I have 6x, I have x minus 1 squared, and now I have 5x minus 2. Alright, so now that I have these 3 factors, so set all the factors equal to 0, and you'll get, okay, that's a factor because it has an x. 0 is one factor. Set the second term equal to 0, and you will get 1. You'll actually get a double root there, but we just need to write it down once. And then 5x minus 2 equals 0, so x equals 2/5. Those are our critical values for this problem. Okay, so let's, in the interest of space, let's do the problem number 12 on the next page. Okay, starting question number 12. They were also asking you for the critical value, and I am noticing that I have not only a quotient rule but also a power rule. So let's start the power rule first. Bring down your power. So I would have 3, and then bring this entire function, 4x minus 1 over 3x plus 1. Then I'm going to multiply that times the derivative of, and I'm going to raise this squared, right? Then multiply it by the derivative of 4x minus 1 over 3x plus 1. So I'm going to start with a box. So that's going to be low d high minus high d low all over low, oops, let me just clean that up, plus 1 squared. Okay, so that's what I have so far. So let's start cleaning this up. Now, because I know I'm finding critical values, I would focus my attention on cleaning up the numerator for the last term. So I'm going to write down what I have originally. F prime of x equals 3 times 4x minus 1 over 3x plus 1 squared. Okay, now look at that numerator. Maybe I'll change to red and we'll do some of that work up here. So that would be 12x plus 4 minus 12x minus a minus 1, so that's positive 1 times 3, so plus 3. Okay, so it looks to me like the 12s will cancel and I'll just have 7 in my numerator. So that sounds pretty good. So this numerator that was a mess turned into just a plain old 7. And then I have 3x plus 1 squared. Alright, so look at this. That's my answer. Now, let's see if we can set it equal to 0. Now, you're going to think this is going to be a nightmare, but it's really not. Okay, the 3 is not a factor, so there's nothing to be going on there. This is a factor. In order for this to be 0, 4x minus 1 has to be 0, and that will happen where x is 1/4. Okay, so that's a root. Now, look at this last term. Is there any value that's going to be 0? And the answer is no. Okay, so I have to eliminate something, make sure it's not in my answer. I can't have this denominator ever go to 0. That will only happen at negative 1/3. So I would have to exclude that. But that doesn't impact my one single critical value, which is a positive 1/4, and we're done. So those are those 4 problems.